Welcome to AK Shah's Foreign Exchange Made Easy class. Today is 23rd session. Last day I covered Black and Scholes model. Today I will continue it and start Binomial model, which is based on American style of option value. In the last class I have said several times n into d1 and n into d2. This is wrong. N d1 n d2 because n is cumulative standard normal distribution and it is used to find out the probability. Now in the last class I have solved this problem. Calculate the price of 3-month European put option on a non-dividend paying stock with a strike price of rupees 50 and when the current stock price is rupees 50 and risk-free interest rate is 10% per annum and volatility is 30% per annum. Here there is no dividend included here. Now the put option value comes out, that is 2.38. Now this portion is added in the previous problem where dividend is expected rupees 1.50 in 2 months. You have to find out the new put price. If dividend is expected of rupees 1.50 in 2 months. In Black and Scholes model, the present value of dividend should be deducted from the stock value. Now 50 minus present value of dividend in 2 months will be 1.50, the dividend, into e to the power minus 1667, that is 2 by 12 into 0.10 is equal to 50 minus 1.50 into e to the power minus 0.1667. That will comes 50 minus 1.475 and new stock price will be 48.52. Now put this value in D1, ln S minus K, that is 48.52 by K50 R plus sigma square by 2 into T, that divided by sigma into root 0.25. Now from this equation, you calculate D1 is equal to 0.0413. Now D2 is equal to D1 minus sigma root T, that is equal to 0.0143 minus 0.15. It comes negative 1.1087. Now n minus D1 is equal to 1 minus n 0.0413, that is equal to the value of the 0.013 will be 0.04 will be 5160. You see here 5160.04. Here it is 0.0413 and you deduct 5160. 1 minus 0.5160, it will be 0.484. N minus D2 is equal to N into minus 0.1087, that is equal to N into 0.1087, and you find out the value 0.1087 is equivalent to 0.11. 0.11, it will be 0.5438. 5438. Now you take the value here 0.5438. Now put the value here P, price of the put option, K into e to the power minus RT n minus D2 minus S n into n minus D1. Now e to the power minus RT, that is equal to e to the power minus 1 R into T is 0.25 is equal to e to the power minus 0.025, it comes 0.9753. Put the value here. K is strike price, 50 into 0.9753 into 0.5438. It is the value of N minus D2. And minus 48.53, that is new strike price, multiplied with 0.484, the value of the N minus D1. Now you solve it and it will come 3.03, the put option value. Next come the problem, Black and Scholes model. Calculate the European call option on a stock where there are ex-dividend dates in 2 months and 5 months. It should be deducted from the stock price. The dividend on each ex-dividend date is expected to be 0.50 rupees 0.50. The current share price is rupees 40. The exercise price, strike price, is rupees 40, that is ATM. The stock price volatility is 30% per annum. The risk-free rate of interest is 9% per annum. And the time to maturity is 6 months. T is 6 months. Find out the European call price. It is given S is equal to current stock price is rupees 40. K is equal to strike price rupees 40. Volatility is 30% per annum. Risk-free interest is 9% per annum. Time to maturity is 6 months. And dividend is rupees 0.50 in 2 months and in 5 months. So it should be deducted from the stock price. So present value of dividend is 0.5 dividend amount into e to the power minus 1667 into 0.09, that is T into R, plus 0.50 0.4167 multiplied with 0.09, that is in 5 months. 5 by 12 is equal to 0.4167 multiplied with R, that comes to 0.5 e to the power minus 0.015, 0.5 e to the power minus 0.0375 is equal to 0.9741. It should be deducted from the stock price. Now stock price will be 40 minus 0.9741 is equal to 39.0259. Now you find out D1. D1 is ln S by K plus R plus sigma square by 2 into T divided by sigma into root T. That is equal to D1 will be 0.2021 and D2 is equal to D1 minus sigma root T is equal to 0.2021 minus 0.212 is equal to minus 0.0099. That is equivalent to 0.01. Now ND1 is equal to 0.202 is equal to 0.5793. You see here 0.202, that is 0.25793. 0.5793 and D2 ND2 is equal to N minus 0.001, that is equal to 1 minus 0.0099, that is equal to equivalent to 0.01. we have to find out the 0.01. 0.01 is 0.5040. 0.5040, and put the value 1 minus 0.5040 is equal to 0.496. Now it is to be computed the call option value. So C is equal to S into ND1 minus K into e to the power minus RT into ND2. That is equal to C is equal to S is 39.0259. 39.0259 we have earlier calculated here, into SD1 is equal to 0.5793. Here it is 0.5793 minus K 40 into e to the power minus RT. R is 0.05, T is 6 months, into D2, ND2, that is equal to 0.496, and e to the power 0.09 into 0.5 is equal to e to the power 0.045, it comes 0.956. So C will be 22.61 minus 40 into 0.956 into ND2 0.496. That will be C is equal to 3.65. Now from Black and Scholes formula, input is, you see here, strike price, spot price, strike price, volatility, time to expiry, and risk-free rate. And output is call and put option premium, delta, gamma, vega, theta, rho. This will come later. I already solved the call and put option premium. Now come binomial pricing model. This methodology is more computational, taken more computing power, and is mainly used to price American option. This is a very accurate model as it is iterative but also very lengthy and time consuming. American option can be exercised any time before its maturity period. When an option holder exercises his right to buy or sell, it may have three possibilities. An option is said to be in the money when it is advantageous to exercise it. When exercise is not advantageous, it is called out of the money, OTM. When option holder does not gain or lose, it is called at the money, ATM. Now come a problem. Consider a 2-year American call option with a strike price of rupees 50 on a stock, the current price of which is rupees 50, that is ATM. Stock price is 50 and strike price is also 50. Assume that there are 2 time periods of 1 year, and in each year the stock price may move up or down by equal percentage of 20%. The risk-free interest rate is 6%. Using binomial option model, calculate the probability of price moving up and down, and draw a 2-step binomial tree showing prices and payoffs at each node. Now what is given? S is equal to 50 and spot price, and strike price is 50, and it is given stock price may move up and down equally by 20%. Rate of interest free is given 6%. Then to find out the probability. Now stock price in 2 steps binomial tree is given, shown here. Note A, the stock price is 50 is taken here. It has to move up by 20%. That is 20% move at node B. It becomes 60, 1.20 into 50, and it moves up and it will be 72, that is 60 into 1.20. And here from the node B there is also a branch, that is it will move down by 20%, that is 0.8, 60 into 0.8, it will be 48. And from node A come to the decreasing line, 0.8, decrease by 0.8, it will be 40. 50 into 0.8, decrease by 20%, that is 0.8, 50 into 0.8 is equal to 40. From here, there are 2 branches. One is upward, one is downward. And here it is increased by 20%. 40 into 1.2 is equal to 48. And 40 into 0.8 is equal to 32. Now this is the outcome of the after 2 years. If you go through this value, D72, the call buyer will exercise here because the strike price is 50. Strike price is 50. So the intrinsic value will be 72 minus 50, that is equal to 22. And here for E48F in this node, the call buyer will not exercise his right because it is below the strike price. So C will be 0 and here C will be 22. Now find out the probability of price increase side. Price increase side, here it is A to B and price decrease side is A to C. Now probability of the price increase side is P is probability, R is the rate of interest, minus D. What is D? That is lower limit value by base value. Here lower limit value is here 40, C is equal to 40 and base value is 50. So 40 divided by 50 is equal to 0.8. And U is upper limit value by base value. That is 60 by 50. At 60, then at node B, 60 is the upper limit value and 50 is the base value. So it is 1.20. Put the value here, you will get probability R minus D, R minus 0.8 by U minus D, that is 1.2 minus 0.8 is equal to 0.65. It is on the increasing side. So decreasing side, the probability will be 1 minus 0.65 is equal to 0.35. You also calculate in the decreasing side also. Then the formula will be P probability is equal to P U minus R divided by U minus D. Where in the increasing side it was R minus D divided by U minus D. But on the decreasing side, the formula will be U minus R divided by U minus D. And 1.20, the value of U is 1.20 minus R 1.06 divided by 1.20 minus 0.80 is equal to 0.35. It is the probability of the decreasing side. So 0.65 will be the probability of the increasing side. Now come the decision tree. Binomial problem. At here 72, you find out first 72 and you put here the probability 0.65, 0.35 in each branch. That is 0.65 and 0.35. Now here C is equal to intrinsic value is equal to 22, 72 minus 50. And here it will be 0, it will be 0. Because here the buyer will not exercise his right. Now at point B, the option value will be 22 multiplied with probability 0.65 plus 0 into multiplied with 0.35, that is equal to 13.49. That divides by interest rate because it will be converted to the present value. Now come here, the call values at DEF will be 22 and 0 respectively. The value of call at node B is equal to 22 into probability 0.65 plus 0 into 0.35, that is probability, divided by 1.06. It is not continuous compounding. If it is continuous compounding, it will be e to the power 1.06 because it is for 1 year. If it is for 6 months, it will be e to the power 1.06 into 0.5. That will come later. It comes 13.49. So the value of the at node B, it is 13.49. And here at point A, it will be 13.49 into 0.65 multiplied with 0 into 0.35 divided by 1.06, you will get 8.272. Now at the point B, 13.49, you should remember this. At node B, early exercise, the trader will pay 10, that is 60 minus 50. That is the intrinsic value, which is less than the value calculated 13.49. Now I have calculated the value is 13.49, which is greater than rupees 10. Using the single period binomial model, hence at node B, the early exercise is not preferable, that is 10 is less than 13.49. So the value of the American option at this node will be rupees 13.49. The call option value of early exercise had been higher than the rupees 13.49. Instead of 10, it is 15. Then that will be taken as the value of the option. The value of option at node A is equal to 13.49 into probability 0.65 plus 0 into 0.35 divided by 1.06. It is 8.272. Next problem. A limited newly listed company. Its listing price is rupees 200, expecting it will rise 40% every 6 months or fall by 20% every 6 months on the half yearly opening price for next 1 year. The weightage being 40%, that is probability for every increase and 60% for every fall. If 1 year option carries a exercise price of rupees 260, you are required to compute the following under the binomial model. Risk-free rate of return, value of call, future value and present value, value of put, future value and present value. Now given in stock price S is equal to 200, strike price K is equal to 260. Market moves upward by 40% and probability is also 40%. And market moved downward by 60% and probability also 60%. Now draw the decision tree. At node A, the stock price is 200, and it is in this way decreasing. That is, at node B, it will decrease by 20%. So the value will be 160. And in point C, it is an increasing mode, that is 40% increase. So the value will be 280. 200 into 1.40 is equal to 280. You see here I write this 280. Now come to D point, node D. Node D, it will decrease by 20%. So it is, see, 160 into 0.8, it is 128. It is 128. So here the call buyer will not exercise his right because his strike price is 260. Now the another branch is here. The probability is 40%. It is an increasing side. 160 into 1.40, you see E is equal to 224. And still here, call buyer will not interested. Now come at the point of C, node C. There are two branch. One is increasing side, another is decreasing side. Increasing, that is 392 means 240 into 1.40. 240 into 1.40. You see here I write at point G, 240 into 1.40, that is equal to 392. And if that is 280 into 0.80, it will be 224. Here the buyer will not exercise his right. Here he will exercise his right, because there is an intrinsic value. 392 minus 260 is equal to 132. Now the value of the at the each point, if you come to C, here the value is the 132. Now at point C, it will be 132 multiplied with 0.4, the probability, plus 0 into 0.60, it will be 52.80. Here I write here. At node C, call price is 132 into 0.4 plus 0 into 0.60 is equal to 52.80. It is future price, not the present price. If you find out the present price, it will be divided by the interest rate. And if that interest is compound annually, not continuous compounded, then it will be divided by e to the power r. Now at point A, the call price will be 52.80 multiplied with probability 0.4 plus 0 into 0.60 is equal to 21.12. Here I write here 52.80 multiplied with 0.40 plus 0 into 0.60 is equal to 21.12. Next come price of put option. Now you already calculated T is equal to 128 and E is equal to 224, F is equal to 224 and G is equal to 392. Here the put option buyer will be interested to exercise his right here because 260 is the strike price and stock price is less than strike price, so intrinsic value will be 132. In this point E, P, the price of the put option will be 36. Here it will be 36, but here he will not exercise his right, so P is equal to 0. Put option value will be 0. Now you have to find out the put option value at B. it will be 132 into 0.60 plus 36 into 0.40, you will get 93.60. You see here at note B, put price is 93.60 is equal to 132 into 0.60 plus 36 into 0.40. It will be 93.60. And at point C, it will be 36 into 0.60 plus 0 into 0.40, it will be 21.60. Here I write here at note C, 36.60, 0 into 0.40, it will be 21.80. And at point A, the price will be 93.60. Here it is 93.60 at node B multiplied with probability 0.6 plus 21.60 multiplied with probability 40, it will be 64.80. So 93.60 into 0.60 plus 21.60 into 0.40 is equal to 64.80. This is totally future price. Now it will be converted to the present price. So you have to find out the risk-free rate of interest. Here it is not there. So risk-free rate of interest, to compute the risk-free rate of interest, you see the previous formula P, probability is equal to R minus D divided by U minus D. That is equal to R is equal to P into U minus D plus D. And U is the upper limit value by base value. Here it is 1.40. And D is equal to lower limit value by base value. It is 0.80. Put the value here. R is equal to P is equal to 0.4. It is increasing side. 0.40 into 1.40 minus 0.8 plus 0.8 is equal to 1.04. Alternatively, you can use here P is equal to, in the decreasing side, U minus R divided by U minus D. That will 1.40 minus 0.6 into 0.6 is equal to 1.04. It is continuous compounding. So it will be converted. E to the power RT is equal to 1.04. Taking natural log E to the power 0.5 R is equal to log 1.04. Antilog 1.5 R is equal to 0.0392. Or R is equal to 0.092 divided by 0.5 is equal to 7.84%. The present value of call option, future value is 21.12. Then the present value of call price at node A, where R is equal to 7.84% and T is equal to 1 year, 21.12 into e to the power minus 0.0784. That is 21.12 divided by e to the power positive 0.0784. And when you multiply it, it will be minus 0.0784. That is equal to 21.12 multiplied with 0.9246 is equal to 19.53. This is the present value. And similarly, the put option value will be 64.80 multiplied with 9.9246 is equal to 59.91. Here, put value is higher because it is for for put option, it is item. The question is given here. K is equal to 260. You see, K is equal to 260 and strike price is 200. So it is OTM for call option and ITM for put option. Here I stop the class. Here next day I will start put call parity. Thank you.